Now, what if you have a little bit more complicated three-axis part? And hold on just one second. I want to double check something. Okay. Okay, so our advanced three-axis method we're calling a flip-n-jig. No, it's not a thingamajig, it's a flip-n-jig. So basically what you're doing is you're machining the first side, then you're flipping it over, and instead of using tabs to hold it together, you're actually going to use a fixture or a jig to hold the part. So again, we're going to start over here on the left. We got the same part as we did in the prior example. We have a part with a feature on both the top and the bottom that needs to be machined, and also the perimeter needs to be machined. So we created, in the middle column, we created the stock box, okay? And we oriented the part within the stock. The orientation of the part in the stock is not as important in this type of flip machining, only because you're going to be using a jig or a fixture to automatically align the part when you flip it. So you just need to, define your stock, well enough, obviously, to machine the top side. So in the bottom here, we see we machined the top side. This is the cut material simulation. We left material on the bottom just to keep it together into the block of the stock, so when you flip it over. And in the third column, you see you have to prepare the jig or the fixture that's going to receive the part once you flip it over. So this will have to be programmed and machined along with the part itself. So the neat thing about, we have a production example coming up. The neat thing about that, in the pro configuration, you can program the top of the part, the bottom of the top, bottom of the part. You can program the jig and the fixture all in one part file, and keep it all together so it's less confusing. So in the—
Hey, Don,
Yes, Joe.
I just want to interject here and say one of the things that might not be apparent, very clear, is the flip that you're doing. You have to flip it about an axis. So basically, the flip means you're rotating about an axis. In this particular case, you can rotate about the x-axis. And then you got to make sure that on the machine tool, you're flipping the part about the same axis.
Yeah.
That is, you're flipping or rotating the part about exactly the same axis. I mean, obviously, you can't rotate the part by a different axis, and then you're going to get into problems. So that's important to observe. So.
Okay. So again, in the third column, we have the in-process stock. We flipped it over. We placed it in the fixture, so it's holding it. Again, we've got a production example coming up. You may be asking, well, how's the part going to stay in the fixture, et cetera, et cetera. We're going to talk about that. So let's go and look at a production example of this flip-n-jig. So if we start on the far left, we have a part that obviously needs to be machined on two sides. So if you look at the cross section of the part with the dimensions over here, we have a curvature on the inside, a curvature on the outside. We've got a flange on the bottom. So obviously you can't machine this all from one side. So we're machining it from the top side. If you look in the second column, many cases also the purple or magenta surfaces. In this particular example, we have critical edges that we don't want to lose the definition of, and those are the sharp corners on the bottom of the part, both on the outside and on the inside. So what we did is you add a surface. The flat surface here is to, again, a place for the tool to land on. So you'll see in the center view here with the arrow coming down, the tool will have to stop on that circular surface right there and not go all the way through. And then the red and the blue dots signify where the parting plane is. In other words, you got to go at least past the blue dot on the inside. And then we have a surface added at one of the red dots so that it guides the tool past this edge. That's what those surfaces are all about. So on the third column, we're machining the bottom of this part first. So we're going to be fixing it when we tip it over. So all we need is just a circular round stock, and we're programming the bottom side. So we have the roughing operations in the top view, and then we have a finishing operation in this view here. So if you move over to the final column on the right, on the bottom, you see the cut material simulation of the part. This is what it's going to look like after the bottom side is machined and you take it off the bed. So you're still going to have a circular stock, you're going to have your flange machined, and then you're going to have half of the inner area machined down past the quadrant plane. And this is the surface that we modeled so that the tool wouldn't go past. So now, depending on the operations you use, you can contain your tool path in the Z-axis. In this particular case, it was more convenient to just put that surface in there. So let's look at it when you flip it over. So in this example, we have a nice circular flange on the bottom of this part, and if you look at it, you can see the flange right here, and that's a perfect feature to fixture the part on. So we have, if you start on the left side at the top, we have the jig or fixture, and you'll see that it has an area for the part flange to sit on, and it's got all these holes around it, and it's got holes in the corners. Optionally, if you want to fasten this down to your table, you can use the holes on the corners, or you can hold it however you want to hold it. If you're using a vacuum table, these holes will help hold the part down, and I'll show you this in more detail in the actual part file. But down here on the left side bottom view, you see that we have the fixture with the part on top of the fixture. Now this is not the cut material simulation, this is the actual part model in the CAD file. So when we machine the top side, we have another flat surface that are shown in green, which is positioned below the quadrant area on the inside to catch the tool. And then we also have this surface that we see in green at the bottom edge. That surface is actually modeled in the fixture as you see it around here. And basically that's just going to guide the tool past that edge to maintain that feature in the actual part after it's machined. So in the second or center column, you'll see in the top, you'll see the in-process stock. It's already been cut on the bottom side. It's been flipped over and it's been set on the jig or fixture. So the alignment of the inner bottom flange aligns with this flange here. So you're basically automatically being aligned along the center of the part itself. And here in the bottom view, we're just showing the roughing operation. And on the view on the far right at the top, you see the finishing operation. So this is the actual cut material simulation. You'll see that it machined it, looks really nice on the inside. It's got an area here that helps guide the tool past this edge here. And if you look at the cross section here, you'll see the edges here on this point and the edges on the inside. Those are all maintained during the machining process. And then also this particular fixture has a chamber on the bottom, which allows the vacuum to be pulled through the fixture and hold the part down during machining. And if you got any questions on this, go ahead and Go ahead.
Yeah, one of the things that I want to point out is, if you're a job shop and you're getting this part, you have to actually think through this process of, how are you going to you have to actually design the fixture yourself as a machinist or a manufacturing engineer. So you can get pretty creative. You can use your creativity actually to figure out what is the best way to fixture it. So we're just giving you examples, but really there's a lot more involved in trying to figure out what is the best way to fixture or create the fixture. And then you actually have to design it in the CAD system and possibly machine it in the CAM system first before you can actually machine the part.
Yeah.
So it's quite complicated. So even though we're glossing over the details a little bit here.
Yeah. Yeah. And, obviously, yeah, I'm just going to reiterate what you said, Joe.
Yeah.
So when you come back and watch the webinar and the recording, you can look at these in more detail, obviously, and as far as take more time than we're taking to go over it. So this is an example of what we're calling a flip and jig. You're machining one side, you're flipping it, you're putting it in a fixture, and you're machining the opposite side.
And not at this point, no.
Okay, we got about 10 minutes. Let's go over the most complicated one. So flip and fix. Let's close the bottom area. So in this one, you can see we got a fairly large machining job. And I'll just go through this, which is the one where we machined it and flipped it over and then set it on this fixture. And then the fixture has a chamber in the bottom. You got holes around it to help hold it down. And basically, we're in this. This will be very, very complicated in the standard configuration. It can be done. I mean, as long as you keep, everything coordinated, everything set up correctly, you won't have a problem doing it in the standard. But it's going to be a lot easier to do it in the Pro. So basically, like I mentioned in the presentation, we machined the bottom half first. So let's go ahead and turn off the fixture. Okay, we'll just roll this over. Okay. So here we're machining the bottom side, facing, machining the lip. Here's our roughing, more roughing, and then finishing. That's side one. Now we're going to create another setup that's going to orient. You'll see that the Z-axis is pointing up. In the setup 2, the Z-axis is pointing down. So now we're going to just rotate this over again. And at this setup, we're going to do the top side. So we have our work 0. We have our roughing. Again, let's turn the fixture on because it's going to be set on top of this fixture. And I mentioned let's turn this toolpath off for a moment. The guide reference surfaces or guide surfaces, I guess you could call them, to help guide the toolpath. We have, let's see, let's turn this up again real quick, and let's turn, okay, top side. Okay, so here's just a flat surface. It's going to a place for the tool to land on. It's oriented past the quadrant, on down a little bit in the part. And let's go ahead and look at the fixture again. This surface right here, which is part of the fixture, is actually going to guide the tool past this edge. So you're going to maintain a sharp edge here as required by the part. Okay, so let's turn the fixture on. We'll turn that off. Okay. And we're at this point, we're machining the top. So again, we got the roughing and we got a horizontal finishing This is a pre-finishing operation and then the final finishing operation. And if you look at this, let's go to a front view. Let's see that, and let's change this so we can somewhat see through it here. Okay. So what you're seeing here is we have this surface. This is part of the fixture. The tool path, the tool is guided past the sharp edge right down onto the fixture, which is really no big deal. It's part of the fixture anyway. So every part, you could just reuse this fixture over and over and just set the part down on there and machine the top side. So now what we was mentioning about the fixture, we actually have, let's see what this is. This is the, okay, we got the fixture here. Let's turn the part off. Let's turn the fixture plate. Okay. Okay. So we've got, let's look at the tool paths here. The fixture itself is a flip part. So it's a two-sided part just to make the fixture. So we made the program, the bottom side, the locator pins, the pocket on the inside. All that is machined out for the bottom side. And then also we got to flip it over and do the top side of the fixture itself. Okay. So basically you're machining the fixture along with the part, flipping the fixture for both sides, flipping the part for both sides. Everything can be maintained in one machining job in one file. And this, this is a relatively complex, but they can get more complex than this depending on the part geometry. So the main thing to remember on each of these types, if at all possible, make sure your part and your stock are aligned in the center in relation to each other, regardless of where you're setting it, where the work zero, where it's going to be on the machine. That none of that matters. Just the part and the stock is centered. Once you define that, then you can locate your work zero somewhere on the stock. That's where it's going to be sitting on the machine. That's where it's going to be, the tool paths are going to be measured from. And then when you flip it over, you use the same location and it maintains the location of the part within the stock. So you just boil that down to one thing that you got to remember is to center the stock and the part, and you should be okay. And if you can't do that, model your stock and position it with the part. But don't forget, after you define your stock based on your model, make sure you turn the model off, turn the geometry off, because if it's visible, three-axis toolpaths, they won't go past your stock and it'll just tell you there's nothing to cut.
Yeah, one other technique that you can use for positioning the part after you flip it is these registration pins,
Yeah.
which Don talked about briefly here. So there's holes on the four sides. You can actually set up registration pins for your part on the stock model. And then when you flip it, you stick it back into those registration pins, and that way the dimensions will be correct in terms of machining from either side. So that's another technique that people use. So
yeah, because this particular part, it has designed to have it aligned here with this area in the fixture, but that's just for this part. So you may not be able to do something like this. So then, as we mentioned in the beginning, when you're looking at this part and you're figuring out in your mind how you're going to program it, you also have to figure out how you're going to fixture it, and you may need to add registration pins if you can't fixture it any other way with clamps or whatever. A lot of times shops will use the registration pins, and that obviously it helps align it when you flip it over. Let's see if we can, actually, we're right at an hour. Do we have any questions, Joe? It looks like, let me take a look here. Okay. Looks like we've covered everything. Okay, here's a question here. Can you post both setups in the top in a TAP file or, any NC file? So,
Yeah, I answered that question
yeah.
actually. So yeah, you can do that, but your post has to be set up for each setup. I mean, I say setup, the post has to be configured. Let me rephrase that. So that when the post processor encounters a setup operation, the correct code is being output. So that code needs to be configured in the setup of the post. So
Yeah.
it can be done.
So whenever what Joe was saying here, if you're posting an entire machining job, you're going to be outputting setup orientation plane codes. So as Joe mentioned, they need to be set up in the post.
If you want to bring up the toolpath editor, I'm sorry, the post processor editor, I can quickly talk about that. So
Okay.
just edit. So go to the setup tab. So yeah, here in the setup tab, right now there's some code set up for setup 0 and setup 1. And if you want to put a pause operation, you need to stick that in here. So when the post processor is running, it will encounter, when it encounters the setup, the code that's in this edit box will be output. So that's how you would do it.
And we can help you set that up if you're
Right.
not familiar with
Yeah.
the post process generator.
If it's something simple, we can help you set up. Since you're all on maintenance, we can help you with that. But if it's something complicated, we can talk about that offline. So.
Okay, it looks like we're about right at 1 hour. If you guys got any more questions, feel free to just email us at support@mecsoft.com. And being AMS subscribers, you get priority support. So if you're not on AMS, you go to the bottom of the support desk line. So every day, all of the AMS subscribers get addressed first, and then after that is done, then the non-AMS subscribers get addressed. So,
all right, thank you, everybody,
okay,
and then see you next month.
okay, y'all take care and have a good evening.